The earth trembles, a prelude to the chaos that is about to unfold. A deep groan rises from the heart of the mountain, echoing through the valleys. Smoke billows skyward, a dark omen against the dawn, signaling impending doom. Then, with a roar that splits the heavens, the volcano erupts violently. Molten rock, a fiery torrent, cascades down the slopes, unstoppable and relentless. Ash, a suffocating blanket, chokes the air for miles around, turning day into night. The very air grows thick with the smell of sulfur, a pungent reminder of nature's raw power and fury. This is the fury of a volcano unleashed, a spectacle both terrifying and awe-inspiring to witness. Volcanoes, these fiery giants, are a stark reminder of the immense forces that shape our planet and its destiny. They're capable of unleashing unimaginable destruction, reshaping landscapes in a matter of hours, leaving nothing untouched. Yet, for all their destructive potential, volcanoes are also a source of life and renewal. Their eruptions, while devastating in the short term, replenish the Earth's soil, making it fertile for new life to flourish and thrive. But what happens when a volcano's fury reaches unprecedented levels beyond our control? What are the consequences for our planet and its inhabitants when these giants truly awaken from their slumber? The answers, as history has shown us time and again, are both sobering and profound, leaving us in awe. The year 1816 is etched in history books as the year without a summer, a time of unprecedented climatic anomaly. The culprit, a volcanic eruption of unimaginable scale half a world away that changed the course of history. Mount Tambora on the Indonesian island of Sumbawa had awakened with a vengeance, unleashing its fury. The eruption of Tambora was like nothing witnessed in recorded history, a true cataclysm. It ejected an estimated 100 cubic kilometers of material into the atmosphere, dwarfing even the famed eruption of Vesuvius that buried Pompeii. The immediate impact was devastating, leaving a trail of destruction. Tsunamis, triggered by the eruption, ravaged coastlines, causing widespread havoc, while pyroclastic flows, rivers of searing gas and ash, incinerated everything in their path, leaving nothing but ash. But the Tambora eruption's reach extended far beyond the shores of Sumbawa, affecting the entire globe. The massive injection of sulfur dioxide into the stratosphere had a chilling effect on the entire planet, altering weather patterns. Global temperatures plummeted, leading to widespread crop failures, famine, and social unrest. A dire situation. In Europe, the summer of 1816 was cold and wet, unlike any other. Crops failed, leading to widespread food shortages and skyrocketing prices, causing panic. Riots erupted as people, desperate for sustenance, took to the streets demanding relief. The societal impact of the Tambora eruption was a stark reminder of humanity's vulnerability to the whims of nature, a lesson in humility. The chilling effect of the Tambora eruption wasn't a mere coincidence, it was a significant climatic event. It was a direct result of the massive amounts of sulfur dioxide gas ejected into the stratosphere, high above the Earth's surface. This gas, a potent reflector of sunlight, acted like a giant sunshade, reducing the amount of solar radiation reaching the Earth's surface significantly. The science behind this phenomenon is well understood and has been extensively studied by scientists. When volcanoes erupt explosively, they inject sulfur dioxide into the stratosphere, the layer of the atmosphere above where weather occurs and clouds form. Unlike volcanic ash, which falls out of the atmosphere relatively quickly, sulfur dioxide can linger in the stratosphere for months or even years, affecting climate. Once in the stratosphere, sulfur dioxide reacts with water vapor to form sulfate aerosols, tiny droplets of sulfuric acid that are highly reflective. These aerosols, highly reflective, act like tiny mirrors, scattering sunlight back into space and reducing the heat reaching Earth. The more sulfate aerosols in the stratosphere, the more sunlight is reflected away from Earth, resulting in a cooling effect on the planet's surface temperature. The year without a summer, a direct consequence of Tambora's sulfurous outpouring, was a stark demonstration of this cooling effect on a global scale. The eruption served as a natural experiment, revealing the intricate link between volcanic eruptions, atmospheric chemistry, and global climate change. Section 4. A World on Edge. Section 5. Preparing for the inevitable.